All right, for the check your understanding in 41-1, the second check your understanding, number 5 and 6, it says, suppose that the student is selected at random from your school. What would the probabilities of each of the following events be? Well, we can't do this because they didn't give us numbers. So what they're really wanting you to do is just to consider the probability that the student plays a trumpet. They want you to know here that this is going to be a really small percentage. And the reason is because we're talking about a student plays trumpet. That's the probability that a student plays trumpet given your whole school. So the number on bottom right here is going to be, a big number. Like my school's not even a big school. But if you go to one of the bigger schools like Southwest High School or O.D. Wyatt or Pascal, then you've got a number down here that's in the thousands, like 1,500 kids, something like that. That's a big number to have on bottom. And the number of kids that play trumpet is going to be, I don't know, maybe in the hundreds. Let's just say 150. So this is going to be a really small number. A really small percentage. But if you now consider the probability that a student plays a trumpet, given that he's in the school band, well, we're no longer talking about such a big number on bottom. The probability that a student plays trumpet, given that they're in the band, well, the band is going to be, I don't know, how many kids? 300 kids? I mean, I'm just guessing. So if you still take those trumpet players, 150, and they could be a trumpet player that's not in the band. That's one of the questions that we have to ask on number 6. But we could, even if it wasn't, let's just say some of those trumpet players are not in the band. We still have a bigger proportion because we're only considering the band members. Okay, so these are just examples. So we'd say a small percentage. A really small percentage, and this would say they just want us to say this is a bigger percentage. And the reason that it's a bigger percentage is, like I said, because the sample size changed. Now we're only considering the people that are in the school band. All right, so the next one says if T represents the people that play trumpet and B represents the students in the band, explain in words the meaning of the given probability. So this is asking us for the people that play trumpet and are in the band. That's what that one is. The number of people that play the trumpet and are in the band. And this is the number of people that are playing trumpet given the band. Trumpet given they're in the band. That's all they wanted us to do, is just explain what that says. So that symbol is and this symbol right here is given. Are these probabilities the same? I say no, they're not the same, because the number of people that play trumpet, these people down here have to be in the band. Okay, so we're only talking about the trumpet players that are in the band. These people right here, they just play the trumpet. They don't have to be in the school band. So these two numbers may not be the same. So that's the difference in these two. And so here, if we have trumpet players that are not in the band, then you're going to have a different number here and here. So I would say no, they're not necessarily the same. They could be, but they're not. And they're also not going to be, because this is the probability of trumpet and the band. This is the sample space here is going to be out of the whole school. And this one's going to be different because this is just going to be out of the band. So it's going to be similar to this one over here. This one is going to be, let's say, the number of trumpet players, which might be 150, plus the band members. Or actually it's times the number of band members, and you multiply. So yeah, it's going to be a different number on top and it has a different sample space. So definitely not the same value. Okay, let's move on to number 7. Some of the truss tortoise animals are tortoises, some are not. Some of the animals, they know their gender, some they do not. So let T right here, this circle is the number of tortoises that we have. This is the ones that we know the gender, the animals that we know the gender of. This wants to know how many animals are at this location. So this is how many tortoises. This is how many tortoises that we know the gender of. This is how many animals we know the gender of, but these are not tortoises. And these are not tortoises, and we do not know their gender. So in order to add the total number of animals, you have to add all of those up. So 24 plus 67, that would be 91 animals. How many of these animals are tortoises? 24. You've got 4 that are tortoises that you do not know the gender of because they're not in that K circle. And then you've got 20 that you do know the gender of. So you have a total of 24 tortoises. How many animals are of known gender? 57. 20 of them are tortoises, 37 of them are some other species of animal. How many of these animals or known genders are tortoises? 20. Right here. In the K column, in the K, so we know their gender and their tortoises. So 20, this group right here is T and K. All right, so given that little thing over here, now they want us to do some conditional probability. Suppose an animal of known gender is selected at random. So the sample space is not all 90, not all 91 animals, but just the ones of known gender. What is the probability that this animal is a tortoise? So, of the known gender right here, we're only selecting those, so that's a total of 57. So 57 goes on bottom, and by the way, this is, what is the probability that the animal is a tortoise given that we know its gender? So there's 57 animals that we know their gender, and then of those 57, 20 of them are tortoises. So use probability notation to write your answer. Round to the nearest thousandths. So 1,000, that's 3 decimal places. So 20 divided by 57 is about 0.351. All right, here they want us to calculate the number of known given that it's a tortoise. So it has to be a tortoise. So that means that the total number of tortoises, which was 24, has to be on bottom. And then of those 24, there were 20 of them that were known gender. Okay, so a total number of tortoises, that was 24. And then the probability that we know its gender, that was 20. So 20 out of 24. Rounded to 3 decimal places is 0.833. So do these represent the same region on the Venn diagram? Yes, they do represent the same region because every time we were talking about these 3 numbers right here. Okay, so we were still talking about just those. We didn't include these out here. So both times we talked about these 3 numbers. However, the answers were not the same because we were talking about the sample space changed here. We had a different sample space than we did over here. Okay, so we explained that. Suppose a tortoise is selected at random. What is the probability that its gender is not known? Okay, so we've talked about the word complement before, And the notation that we use is a superscript, a little c right there. So suppose a tortoise is selected at random. So that tells me that I'm picking from the sample space of tortoises. That's 24. So I'm saying, given that it's a tortoise, okay, what is the probability? That's what I'm looking for. This is the desired event, that its gender is not known. So this is not K. All right, so the ones that are not known, given that it's a tortoise, I believe is 4. Let's go back up to the, okay. So yeah, so there's a total of 24 tortoises, and this right here is not in K. So this is not K. All right. And 4 out of 24 is 1/6, I believe. And that reduces down to 0.167, rounded to 3 decimal places. Okay, that gets us to this check your understanding, and that ends this. So my next video will be of the answer key to the check your understanding and the lesson practice.